Hey guys, welcome back to another episode of TinkChat. Today we're going to be talking about the state of the 3D printing industry in 2021. I know only roughly 3 months, 2 months has passed, but a lot of things have happened during these 2 months. And we're here to cover it up. I mean, not cover it up, cover with you on what's happening.
Yeah, so some really interesting topics, I would say moments in the 3D printing industry is actually happening right now. We'll cover it as we go. There's a big interest in 3D printing again. I mean, the interest is emerging. I mean, we saw the capital markets also show interest in all the 3D printing companies around the world. I mean, just look at I mean, you probably don't know this person, but there's a person by the name of Kathy Woods that literally built a ETF that just tracks all the 3D printing stuff that's happening.
Wow.
And it's growing at pretty insane rates right now. So capital markets are looking at the industry. I mean, is this a scenario where 3D printing through COVID helped expose it a little bit more? Or is it one of those moments where the industry is now kind of coming out of a bit of a winter and going into a transition from talking about technology to talking about applications? I mean, I covered a little bit of in my histories episode, right?
I think COVID actually did kind of bring the spotlight onto 3D printing, especially with all the supply shortages and everything. It's just 3D printing just shined. And now I guess maybe that's why it jumpstarted the industry all over again.
Perhaps it's a different conversation, right? I think you're right that it probably jumpstarted it to a certain degree. But yeah, the conversation is a little different this time though. It's interesting, and let us jump right into it. I mean, I'm gonna go first.
Okay. Sure.
Right?
Go ahead.
So, late 2020, beginning of 2021, we saw what we tend to agree as we're calling it the desktop metal segment that has come about from really two main companies, Desktop Metal and another company by the name of Markforged. Both introduced a 3D printing technology that is based off of metal injection molding tech from the old days, where you take a metal-based material, you put it with a wax plastic composite, and you put it into a bit of a rod type system. It's it's kind of like filament, but it's in short rods. It's like this one, right? And once you print your part, you put it through a debinding process and then a sintering process.
Okay.
Those systems are now being introduced into larger institutional places. It's probably the one metal-based technology that allows for the lowest cost entry into metal-based printing. It's kind of like FDM.
Yeah.
Pretty much the technology that we build these machines back there, but with metal.
Yeah.
And both companies actually are going public. Actually, one of them is already public. Desktop Metal is a public company. They went and did a reverse merger transaction in the US. And then Markforged just recently, I think it was last month. Is that correct? Or maybe, February sometime.
Something like that. They both of them either acquired or merged with someone.
Yeah. And so the desktop segment, I think, is going to grow.
Yeah.
There's no doubt in my mind that it will grow. It makes sense.
If you think about it, not desktop, but metal 3D printing has always been more of a more industrialized technology. You only see bigger companies, manufacturing companies like car companies or like aerospace companies that are using this technology. And it's been already so many years, so I think it is time for it to actually trickle down to the smaller businesses or medium-sized smaller businesses or even consumers.
I think it's actually cost point. See, up until this point, most of the metal-based technologies has been built around laser sintering, binder jet, and then something that requires like a large industrial furnace. These two technologies are the only ones that so far has proven to be more consumer ready business ready,
miniaturized, I'm guessing.
and less messy.
Yeah.
You know, see the thing with FDM-based technologies or filament extrusion-based technologies is that you don't have to deal with powder, you don't have to deal with resin, you don't have to deal with post-processing, right?
Yeah.
Prints come off and you can handle them right away. The difference with these ones is that you can kind of handle them. They're in a bit of a green state, so they're not quite fully formed.
Yeah.
And then you bake them. You literally bake them.
Yeah.
I'm simplifying this. And yeah, you wait for it and it comes out the part shape, but actually it's metal. So we're not dealing with composites. We're dealing with a finished metal thing. That is a solid chunk of.
And so this solid new chunk of, I guess, model or part that they print out, they can actually put it into the final product?
Yeah.
Okay.
So, I mean, if there is like a copper material, which I know one of I think Desktop Metal is doing.
Yeah.
Like it will come out copper.
Full copper.
Not 80% copper, full copper. They're literally burning off the wax. Well, they're debinding the wax material and then they're burning off the plastic material through a kind of a two-stage process. And if you think about like those large industrial-based machines, like those are a couple $100,000.
Yeah.
These, I mean, they're still a couple $100,000 for the whole entire system.
Yeah.
But it's not, $250,000 just for the 3D printer and then a giant industrial furnace. Right. So, it's a cheaper. Well, I want to use the word more affordable entry point.
Yeah.
And it's also an easier technology to tap into.
Yeah.
And no hazmat suits, like the thing with powder is you have to worry about breathing in that material, which is is
super fine material that you probably can't.
It's never coming out once it goes into your lungs.
Yeah.
So, anyways, these two companies, probably I would say at the forefront of the desktop metal segment, both going and doing an IPO.
Yeah.
Both raising capital and really building out their, I guess, portfolio of products, and it's kind of exciting to see where that's going to go.
Yeah.
I do still believe that the powder technology probably gives you a little bit of a more finer control at the end of the day, right? If you think about it, you print something, and this is for all the viewers out there interested about this technology, print something of a specific size. Let's just say I'm going to print a super simple, a 2-inch cube. When you sinter it and you debind it, it actually shrinks. So when you actually model it, or the software that they have, the software package they have to compensate and they have to know what the shrinkage factor is. Otherwise, your model is going to be totally different.
Wouldn't you be able to do this with this technology as well? After the first try and error, you can measure afterwards and just calculate it.
Yeah, but people don't model that way.
Oh.
Right? So the software probably have to compensate without you knowing.
So that's true.
You model a 2-inch cube, you're going to go 2 inches on the X, 2 inches on the Y, 2 inches on the Z. You're not going to do 2.25 inches on the Y, and So, I mean, I'm pretty sure the technology, they figured out the shrinkage factor for all the stuff, and they're just building it into the software, but that's going to have to be accounted for.
Yeah.
Right. And, but yeah, I think what's really interesting is there hasn't been a new technology IPO in this space for a while.
Yeah.
Like some of the larger companies out there, they've been doing their core business for, like 25 years.
Just expanding on that.
And this is, I think, the first time where we've seen a new company come out with new technology in the space that is setting up as a new company versus just being acquired or merged into another company. So it's pretty exciting. Pretty exciting. Okay. I think this is the topic that I think everyone's covering in this industry right now, and that is as of this last week, the technology patent for heated chambers or build ovens or whatever you want to call them expired. This was a patent that Stratasys held for their FDM technology. And the FDM technology is also the technology that is most widely used across the board by all 3D printer, I want to call it consumer 3D printers out there, the desktop market segment. And if you look at the actual industry itself, the industry built a lot of ways around this patent.
Yeah.
Like a heated bed is a way around the heated chamber patent. But it was a way to address a problem by not really solving the problem. So
Well,
brief scientific lesson, because it's very important to know this.
yeah,
When plastic heats up, it expands.
yeah,
Anything
anything
expands
expands
when it
and-
heats up, and when it shrinks, it contracts.
yeah,
So when you're building an object in 3D, if the material has a lot of contraction and expansion,
mm-hmm.
it will actually rip its own layers apart.
Yeah,
And so, like if you're printing with an engineering plastic like ABS, which has typically quite a lot of shrinkage, if you print a really tall object, like even if it's, I want to say, I don't know, what is that, 20 centimeters, 25 centimeters, by the time you're done, the part would have been laminated in the middle at least maybe 3 to 4 times.
yeah,
And that's with a heated bed.
yeah,
But a heated chamber, what it does is it heats up the whole entire volume, it keeps the plastic warm, and it slowly cools it down, and it keeps the part from just ripping itself apart.
yeah.
That was what was preventing all the consumer desktop printers from entering the marketplace of really interesting thermoplastics.
Mm-hmm.
Things like Peak,
Yeah,
like well, I want to say Peak and Alton, pretty much the same. You've got PVC and all those exotic, but those thermoplastics with very interesting characteristics.
mm-hmm.
They all need this tech.
Yeah,
and so I think what's going to happen is companies that are in that like upper professional market, not the real consumer stuff,
mm-hmm.
that's going to stay with PLA and.
Well, I don't know. I'm sure consumers will be very happy to have this technology upgrade.
I don't think it's going to trickle down to the $700 printers. I don't think it's going to trickle down to even the sub $2,000 printers, because this technology is fundamentally more expensive to make. If you just think about it. And it comes with a totally different thing that no one's talking about. When you start to work with those thermoplastics that are like Peak and Alton, fumes. So you can't just have an oven, you got to be able to handle the fumes that come out of it.
Yeah.
And then the second is when you start printing with those plastics, you end up having to deal with the moisture absorbency of those materials.
Mm-hmm.
So there's a big unfolding of questions here, but all the high-end stuff, high-end machines, well, higher end machines, I want to say like $3,000 to like the $7,000 range machines, most likely going to see this technology.
Well, now that a patent expires, it gives a lot of leeway to a lot of manufacturers out there to actually upgrade or come up with new technology that would satisfy the consumers, right? Or the needs.
I think there's also one interesting thing about the tech. You know how parts, when they print on like blue tape or like heated bed, they like stick really well?
Stick with all the bed leveling.
Yeah.
Correct. Yes.
So a heated chamber, then if you build it well, you can actually print on glass.
Directly.
Yeah.
Yeah.
And when the glass cools down, when the print cools down, it should just be pick upable.
You can just pick it up.
Because it's not going to, like those are the little user experience things that's going to fundamentally change that no one's going to talk about and no one really knows. And I think heated beds may go away. Or maybe they'll get shifted down into the cheaper end. I mean, they're already there, the lower end market. But like this is exciting. This was a patent that a lot of those in the 3D printing industry were waiting to expire.
Well, this was, I believe I was reading, it was the last part of the whole thing. There was like 3 patents on the whole heated chamber, but this is finally the last part that actually allows everyone to have creative freedom.
Yeah.
That expired in last week.
Yeah, I'm pretty excited to like PLA doesn't really need much of anything if you think about it. PLA, for those that are watching, that's the material choice pretty much all 3D printing companies are using these days. And we first designed our machine for ABS, but ABS warps and pops off and does all funky things.
Well, you also need a ventilator for that too.
Yeah. I mean, some would argue the smell of ABS is bad, and I've talked to some people, they like the smell. It's bizarre.
That's interesting.
Yeah. But yes, I think there comes a lot more things to discuss when you start to introduce capacity for material, and like these machines that will come out with heated chambers later on, they're going to enable anyone to use all sorts, like pretty much all the material choices that the larger manufacturers are using. But with the caveat that no one's really going to be installing like an HVAC system in their bedroom that filters air, right? These are what the larger institutional companies and places are actually putting in.
Yeah.
So, toxicity is a thing, and that's something that the 3D printing industry, not the industrial side, but the consumer desktop side, that's what they're gonna have to figure out.
Yeah.
Because I can't imagine printing like Alton at home and walking into a room of, I don't even know what kind of fumes are, and you just don't want to do that.
Yeah.
So filters, for anyone that makes machines that's watching this, that's important. Can't leave that out. But if you're making a machine just for PLA,
it's totally fine.
Go for it.
Okay. I mean, it'll also still help PLA.
Anything will help.
Yeah.
Right. Anything will help. So I mean, from a company's perspective, we're pretty excited about the technology and what it is going to allow us to do for exploring other material choices and all that other stuff. And who's to say we're not already kind of thinking about it? So I'm going to skip that and let Andy handle the next segment. And
So other than the patent expiring, there's also back to acquisitions in 3D printing in UK. Well, actually, this company is called 3D Print UK. They also actually acquired another company called Additive. So essentially, they provide 3D Print UK provides a service of like 3D printing for you, and then the Additive side actually post-process it for you. So they found that post-processing is actually a very big and big demand from other companies, that all the parts have to be processed to be beautiful, nice afterwards. This is why they made this acquisition, so that there's a whole, I guess, kind of like a ecosystem.
They're going for like a vertically integrated type of business model.
Yeah. And they found that it was pretty important to expand their business to also include the service in UK. And I would say, there is a lot of post-processing after prints. We've at Tinkerine, we tried a lot in a lot of ways on trying to find the best way to maybe smooth something, have something glued together, how to paint something. Like, we tried a lot of things, and we have found some favorite ways on post-processing, but it does take in a lot of time afterwards to actually perfect it.
I think the other thing too is making a 3D printed object look like its injection molded counterpart. That just the sanding, the filling, all that takes a lot of time and labor. Yeah.
So in the film industry, I'm not sure if a lot of you know, in the film industry, most props now, or I would say probably 90% of the props are actually 3D printed now.
Yeah.
So everything that you see in movies are actually 3D printed, and the person that's in charge of making these props spend like weeks on just sanding it down, gluing it together, painting and everything before it looks like what it looks like on screen.
Yeah. I can see the reasoning for this.
Yeah.
There isn't a lot of people out there that actually have the know-how and the expertise to do a lot of what you just mentioned. And I mean, that's the movie industry too, right? You got to keep in mind, the movie industry puts a thing in the set and they never ever get close to it, short of it being on on screen for a couple of minutes. But when you're actually holding a physical product and you're buying something from someone, like I've realized half the stuff when I see people post like Kickstarters and stuff like that, the second I see an object, I'm like, yeah, that's 3D printed. I'm like, oh, okay. Like, and that's because we know it so well. But some people have tried really hard to make their product out of additive and make it seem like it is injection molded, and that's actually good. It's good. Because the closer additive technology gets to what we realize or we perceive as a finished good, the more that it can be adopted into the various aspects of everything that we make. So, yeah, service bureau is an interesting business.
Yeah.
And I mean, there's many different ways to do 3D printing service bureau. You can print for somebody, you can do post-processing, you can do design work, you can do a whole bunch of stuff.
Yeah.
We also then, I think it was recently, maybe early in the, like a month ago, a whole bunch of stuff happened in February, February timeframe. 3D Hubs also got acquired. For those that know 3D Hubs, they are a decentralized network of, well, they connect people to manufacturers. They first started, when we first got to know them, they first started out as a community-driven platform for people with 3D printable files to be connected to
a
customers
person that can help you print it.
Yeah, and most of those people are just home hobbyists with a machine on the side.
I would go to 3D Hubs, and 3D Hubs will point me towards Eugene, who has a 3D printer, and I don't have a 3D printer. I'm just looking for my thing to get printed. And then it'll connect us, and then I'll let him know what settings I want, what I'm looking for, and everything, and then he will print the object for me.
Yeah. They've since changed their business model though. They don't do that anymore.
Yeah, but that's what they started with.
Yeah. So they shifted from that business model to a business model where they're doing injection molding. They're doing again vertically integrated services, 3D printing, CNC, injection molding, all that. And they got acquired by a really large company by the name of Protolabs. Anyone in the prototyping and engineering space knows Protolabs. Like they were like one of the biggest guys in the US. And again, they brought them in for vertical integration. There's a common theme here. I think the service side is seeing a consolidation on service on businesses that are kind of within the same realm, and they're all looking to vertically integrate. And so instead of getting like 50 different options, I think we're going to end up with a select few really good quality options, which I suppose is good for everyone in the industry.
I mean, companies always want the biggest
market
piece
share
of the pie.
I mean,
makes sense.
I think as long as it continues to offer really great value. And that means faster turnaround time, better access to services.
At least that's what they said in the article. That's what they were aiming for. Protolabs is able to help you deliver or fast turnaround times. Right away, and that was one of the biggest reason why they acquired 3D Hubs is for their whole expansion network and everything.
I think there's one more company. It's by the name of Voodoo. Voodoo Manufacturing. If I remember correctly, Voodoo was a division under MakerBot. It was like their print service department, or at least the people that started it. I think, if I remember correctly, that was how Voodoo came about. But they also got acquired
recently.
Yeah, they got acquired recently. Who did it?
I think it was 3D Printing Tech. Acquired them recently. The thing is, Voodoo actually closed its door last year due to COVID. I mean, they did try to pivot, and they changed 2 of their printing farms to like printing PPEs. But apparently, manufacturing those PPEs and just the time to actually look after all those farms was running cost was too high for them, and eventually they closed the doors. And now they're acquired by 3D Printing Tech.
They were heading down automated FDM printing. Pretty much having a wall of printers and then a robotic arm that would go and pick the beds out. And then replace them with clean beds, and then press a button. I thought that I mean, the whole idea about this automated 3D printing concept makes sense. So it's interesting to see what 3D Printing Tech's going to do with this acquisition. Time will tell, I suppose.
Well, I mean, I'm guessing it's another strategic acquisition, right? It's another vertical expansion, I'm guessing.
Maybe. Perhaps they've got an automated thing that they figured out that they were trying to really scale that they can, that 3D printing tech can scale with.
Yeah.
So it's interesting that these things are happening in pockets, right?
Yeah.
Like if you think about it, Metal Desktop segment doing IPOs, both of the companies in that segment doing IPOs, and like you can argue that they're trying to compete with each other for market share and also growth potential, right? And then all of a sudden you get this consolidation of market with regards to services. So like it makes sense. The timing of all these things kind of makes sense, given that there is interest in the 3D printing space again. So yeah, I mean, that's not just, I think you looked up an article that talked about kind of emerging tech, emerging fusions of tech. Maybe that's
fusion of tech. Yeah, it was by Mantle, the 3D printer manufacturer Mantle. They actually came up with a new technology. It's called
Trushape?
Yeah, new Trushape Hybrid 3D. And apparently, when I was reading the article, it sounds like it's a combination of CNC machines and a 3D printer, like together. How it works is it 3D prints the shape, like a rough shape of it, and afterwards it's like a CNC, and it takes away material from your block of material that you 3D printed roughly, and then afterwards you have your print. I mean your finished print. It sounded like when I was reading the article.
Right. Kind of makes sense.
But I don't know. I was just thinking, why would you? It's a new emerging and I guess interesting technology. But then doesn't that just defeat the purpose of a 3D printer? Like 3D printer, you can print all these organic shapes and everything, but with CNCs you can't do that. And now you're combining it, and it seems like a whole limiting factor, which doesn't seem to be very useful.
No, I think there's a different way to approach this thought here.
Yeah.
And I think you and I are in this space because we love direct 3D printing of objects, right? So getting dimensional accuracy on the actual part you're making without doing much more to the part. But like there are certain industries that work in microns of tolerances. When I say microns, like 10 microns of tolerances, or even tighter, right? And they may not want to do organic shapes. They may not want to do like the Voronoi with holes in them and super organic.
What we've seen in industry is organic shapes are a lot more rigid and stronger than our traditional shapes.
That's correct, but I think if you want to come at it from a different angle, CNC is very wasteful. Subtractive manufacturing is extremely wasteful when you start with a billet material, right? Like it's a chunk of aluminum, yet they're big.
They're still doing it. It's just probably less material to chip off now.
But that's the thing. Less material, more efficiency.
But it took away the best part of a 3D printer.
No, but it brought some of the benefits of 3D printing to CNC. You see that difference? See, you're thinking of the best parts of the 3D printer is where it must be able to do these, but what they're thinking about it from the perspective of combining the best parts of additive, which is getting the shape as close as it can be, and then machining the rest away. We minimize waste, we minimize time, because CNC is a lot longer. Okay, a bit of a technical glitch there. But I'm gonna keep going. So the best part of 3D printing isn't just about being able to make all the organic shapes and the direct to 3D printing, but it's also the fact that it's very minimal in waste. Like that's a fact.
Yes.
Right? And contrary to that, CNC is huge waste. And then you got to recycle that waste back into a billet, and then you got to CNC the billet again. Right? But if they can combine the good aspect of 3D printing, which is the minimal waste, so that they're only just machining, I don't know, a quarter of it, whatever, that's good. And that means that the CNC industry may become more efficient. I don't think this is actually a
3D printing.
3D printing with CNC capability. I mean, okay, sorry, it is. It is. but it really should be positioned more as this is a CNC machine
Yeah.
that incorporates one of the really good aspects of 3D printing, which is waste management.
Yeah.
Because ultimately, you're right, they can't do organic shapes, not those generative designs that computers do with hollowed insides, and they can't do that.
I mean,
right?
why I'm arguing from that way is because it seems like with 3D printers, the fact that you can do that, it minimizes waste, as you said. It's stronger and it's also lighter. That's the whole point.
But you
point
don't
of it,
get
right?
the dimensional tolerances that a CNC can achieve. At least not yet. Right?
Yeah.
I mean, don't get me wrong. 3D printed parts, those organic shapes with those mounting holes for any of those like supercars that we're seeing with those alternative design, that's happening.
Yeah.
Where they 3D print the thing, super hollowed out, and then they only keep the parts that needs to be machinable. This isn't for that. I don't think this is for that.
Well,
I mean, prove me wrong.
I don't know who is it for, but
it's for those CNC shops that want to be more efficient, right? That wants to maybe use different materials that they can weld together, which is essentially what it is. They weld it together first, and then they machine everything away, which, like, certain materials can't do that.
Yeah.
And then you end up with this alternative way to do subtractive.
Yeah.
That makes sense to me. Like, and now we don't have to start with the billet. We can start off with whatever shape we want.
Yeah.
And, well, to a certain degree, can't be organic shapes. But we can change the dialogue about how we do things in more efficiently. Every industry looks for efficiencies, right? That makes sense. But I think a lot of times it's deciphering the marketing message. Yeah. Right? Is it a 3D printing with CNC capabilities, or is it a CNC with 3D printing added benefits? I think this is more of that.
Maybe why I thought the way I thought was because Mantle itself is actually a 3D printer manufacturer, right? Which is why I would think, why would they take away the best part of a 3D printer and add it into a CNC machine? So no, that was just my train of thought.
Right. I don't think that's wrong. I actually don't. And I think a lot of people that will look at it and say, well, what if I then go and print a super complex geometric shape that has holes and insides that CNC machine arms can't get to? Can the Mantle machine do that for me? Can they machine the outside and somehow go on the inside? The quick answer to that, no, they can't. No, they can't. And if they could, they would have built the world's most breakthrough technology around 3D printing and CNCs, right? But that's we're constrained to the physics of, like, you have to move this giant thing inside and at weird angles. You just can't do it.
Yeah.
So I still do think it's cool. I still do think it's like these type of innovation benefits us. When I say us, larger industry. And it makes manufacturing more efficient. That's what 3D printing is supposed to do, make manufacturing more efficient. I give them props for doing that.
Wow. Yeah, I mean, not that, well, I guess I am saying that, I don't know why they did that, but yeah, I guess it is a breakthrough when you point it out that way, that it's actually like more for CNC machines, making it more effective, more efficient. Yeah.
And they probably are starting with a wire feed too. So instead of ordering like a giant chunk of aluminum, they can maybe use like a wire feed aluminum. Yeah. And so that wire feed can be changed into any shape. So, like, I don't know. I think if you ask me if we were to buy a CNC machine, like, and you ask me, do I want that features? Yeah, I do. Oh,
interesting.
Right? Like,
well, I just haven't seen any. Well, in my mind, I haven't seen a use for it. Like
because you could do it the old way still. If you,
like the old way seems to be, yes, it's more wasteful, but seems to be better. I don't know.
Better is subjective, right?
Yeah.
And I'm making a couple of assumptions that the outcome of the object
Yeah.
is just as strong as a bill of material.
Well,
Because
I
if
don't
it's
know.
because if it's not,
Yeah.
then I will use a bill of material where bill
Yeah.
of materials needed because
Yeah.
it's strength.
Yeah.
But if it has microfractures inside,
Yeah.
because of the added layers, then no, I do not want that. So yeah. I guess you did not tell them.
I guess we are. We're
Give me
done.
a second. Give me a second. Okay, I think that's good enough for this episode. I think, 2021 is looking to be a pretty exciting year for 3D printing.
Yeah.
Some really great acquisitions, some really great IPOs or RTOs or SPAC-based mergers in the US, and some new exciting technologies potentially coming our way. I think what we're going to probably see later this year is a whole bunch of the desktop 3D printing companies come up with new machines because of the patent coming off. That, I think, is pretty exciting. I'm interested to see what happens because markets are going to shift again. Consumer desktop printers are going to have more capabilities of that of industrial printers. And so are we going to eat into that market share a little bit more?
Well, I don't know.
Well, time will tell. I guess we don't have foresight to that. So that's it for this episode, guys. If you like the content, leave a comment in the section below.
Press the subscribe button, also the bell button, so that you know every episode that we release. And also, it's still going to be uploaded to Anchor and Spotify. So if you don't have time to watch a video, you can just listen to us, listen to our voice, chat away. Yeah. So we'll see you next time then.
All right. Take care, guys.
Bye.
Bye.